list out several cases in the previous page. Okay, so if there's a root, okay, if it's an even root, like square root, quarter root, like root 4, root 6, you need to have the things in the root to be positive. If you have a fraction, your denominator cannot be 0. If you have a log, the thing you put into log must be greater than 0, and we have some combinations. Basically, we just have the first 3, okay? That's the basic thing. We have the first 3 with restrictions by its function. So let's look at some example here. Okay, we have square root and we have a fraction. So 1 minus 5x must be greater than 0. Combine the fact that the thing in the square root must be greater or equals to 0. At the same time, the denominator cannot be 0. So basically, I need to solve 1 minus 5x greater than 0. In your test, there's one question asked the domain for the square root function. Okay, for the square root function. A lot of you write 6 instead of 3, I think. You need to solve the thing under the square root to be greater or equals to 0. The x value you find out is the implied domain for the square root function. Okay, not the 6. Do not look at the number itself. Okay, try to solve for the equation under the square root. Okay, so let's have a look at number 3. I have 2x squared minus x minus 6 to take the square root. So the thing under the square root must be greater or equals to 0. But this is a quadratic inequality. Okay, quadratic inequality. Remember that except linear inequality, all the other inequalities, you need a graph to help you to find out the answer. Okay, for example, cubic inequality, quartic inequality, any other inequalities except linear inequality, you need a graph to help you to solve for it. For example, this one. I will factorize that first. Let's say 2 is 1 and 2. 6, I will put 2 and 3. Okay, I need a negative 1, so I need a negative here. So negative 4 plus 3 will give me negative 1, which is correct. So I will factorize that as x minus 2 and 2x plus 3, greater or equals to 0. Okay, so that's this coefficient, and this coefficient give you this give you this. So is which two number can make the coefficient? Okay, that's this method. The next thing I will do is sketch. Okay, sketch the left-hand side. Remember, the right-hand side always needs to be 0. And I will sketch the left-hand side. Okay, if I want to sketch left-hand side is a quadratic. I have 2, 0 as the intercept. And I have negative 3 over 2 is the intercept. Okay, negative 3 over 2 is the intercept, and 2 is the intercept. If I sketch the left-hand side, and it's a happy graph, smile face, because the positive x squared. So the graph will look like this, roughly. I don't care about the turning point for this case. I just roughly draw the graph, find the x-intercept. Okay, so I want greater than 0. I want the part greater than 0, which is the value above the x-axis. I want this part of the graph and this part of the graph. That's the part of graph that is greater than 0, right? Y value greater than 0. So what you're looking for is the x value can make the y value greater than 0. So what x value can make the y value greater than 0 is this part of the x and this part of the x. Okay? So this x will correspond to the graph, this part of the graph, and this part will be this graph. So those x and those x will be the answer. So what are the x? Is x smaller than negative 3 on 2? Okay, I'll write it here. X smaller than negative 3 on 2, or equals to, because we have the equal sign, can equals to 0. X smaller or equals to negative 3 on 2, or x greater or equals to 2. Okay, we have two set of values. I will write it in the set notation. I will say x belongs to negative infinity. Make sure you know how to write infinity, okay? Do not write 8, write infinity to negative 3 over 2 included. Okay, union means and, okay? Do not write comma. Comma doesn't mean union, okay? Write union and 2 to infinity. Okay, that's the correct set notation, okay? That's the correct set notation. We need to write in that way. Okay, for the next one, we have square root 4x plus 1. So, first of all, 4x plus 1 must be greater or equals to 0. Second, 2x minus 1 cannot be 0. Okay, my x value must satisfy both situations. Okay, the thing in the square root must be greater or equals to 0. The thing under the denominator cannot be 0. Let's solve for this. So if you solve this out, you will have x greater or equals to minus a quarter, and you will solve out x cannot be a half. Okay, x cannot be a half. If we can see this on the number line, okay, if we can see this on the number line, we have negative a quarter here and a half here. So I want x greater or equals to negative a quarter. I will have this part of the graph. And can't be a half. So this will be an open circle on this line. I cannot take a half. So I have two ways to write my set notation. The first one, I can write x belongs to from negative a quarter to infinity, except, okay, exclude a single value, which is a half. This must be in the curly bracket. Must be in the curly bracket. Not square bracket, not round bracket, must be in a curly bracket, which means that's a set. A set exclude another set. The second way I can write is from negative a quarter to a half, excluded, union, a half to infinity, excluded. Okay, I just exclude that points. Okay, so I have two ways to write this. For number 5 and number 6, so I will write the equation out. I need the denominator cannot be 0. Also, the thing in the square root must be greater or equals to 0. Therefore, I want this quadratic to be greater than 0. Not equals to because it's denominator. I'll leave yourself to do this by yourself, okay? Solve inequalities using the graph. And the next one, I want this to be greater than 0 as well, because log something must be positive. Okay, you can only put positive numbers in log. Okay, that's one thing. It's basic knowledge, okay? You need this technique to do a lot of questions in year 12. It might be a big application question, and 1 mark is asking you to find inequalities for something. So you must know this. Okay, that's inequalities, and 1C is talk about implied domain and range. I'm not going to talk about that. Make sure you know how to sketch this type of question. Can you see this graph, this one-to-many graph? Make sure you know how to sketch this. X equals to a y quadratic, okay? It's a quadratic, but swap the position of x and y. Make sure you know how to sketch that. If you have question about this, email to me and I'll explain to you individually. That's all function thing, that's all year 11 thing. And I give you a chart here, okay, this page. I find like you are pretty slow in recognize what type of function is one-to-one, many-to-one, one-to-many, like you're, because when I see your question 1, some of you try to sketch the graph one by one. I try to think about what are they. It's a good idea to make you understand. For example, for linear, it is one-to-one. For hyperbola, it is one-to-one. For truncus, it's a many-to-one. Okay, so there are like particular type with particular type of functions. So that's a summary. Okay, I summarize all the type of functions you will learn in year 12, and it's, whether it's a one-to-one, a many-to-one, one-to-many, what type of functions are they, whether it is function or not. Okay, if it's a one-to-one function, we can find inverse, that kind of thing. Okay, it's just something for you to, maybe it's good to put in your reference book. Okay, put in your reference book. You can take a bulk notes to your exam, part 2 exam. That might be something you want to put in and to check your answers. Okay. Next one is piecewise function, or called hybrid function. One thing I want to say is, okay, give you a simple example here. Say fx equals to x when x greater than 0, equals to negative x when x smaller equals to 0. Okay, now I want you to find the y value when x equals to 1. Okay, in this case, you are not substitute 1 in both equations. You are trying to find where is the suitable domain for me. 1 is a number greater than 0. So that equation greater than 0. So I will only substitute this 1 into the top line, not the bottom line. So my f1 will only equals to 1. My f1 not equals to 1 or negative 1. Okay, that's not the answer. I see half of the class for that hybrid function give me question like this. Okay, give me this answer. I want to substitute a point. You will only have one y value. It is a function. Each x only corresponding to one y value, not 2. If you give me 2, which means this is not a function anymore. Okay? So if x equals to 1, you will only have one y value, not this one. Okay? Absolutely not. So if you make this mistake, make sure you don't make it next time. That's really a common mistake. I see year 11, year 12 students all make this mistake. So remember, hybrid function is just a couple of functions get together and put as a function. So each x value only corresponding to one y value. You will choose a suitable one to substitute that value. Okay? So that's the thing I want to talk about. For sketching, I'm not going to talk about this. Even and odd functions, I'm not going to talk about this. Come to sum and product of functions. Okay, that's the new thing. Okay, sum and products of functions. Okay, tell the truth. In VC exam, I never see someone ask you to draw a function by sum of functions. For example, give you fx, give you gx, and ask you to sketch the sum of them. I never seen such questions. But like there are some idea you must understand, or there are something you need to understand first. Is the rule. How we can find the rule? You need to find the rule. So sum of functions is basically sum to functions, sum fx and gx. The only thing we care about is the domain. Can see all the same. The domain will be the intersection between the two functions. No matter it's sum, subtract, product, or divide, it's always the intersection between the two functions. Why that happens? Think about we have two functions here. Think about we have x squared, and then we have square root x, and I want to sum them. Okay, for x squared, the domain will be R. For square root x, the domain will be R plus union 0. Okay, I want the intersection. The intersection will be 0 to infinity. So the sum of function, the domain will be 0 to infinity, not R. Why must be the intersection? Because think about, I want to sum them. I need to have fx and I need to have gx. But for the left-hand side, I only have fx. I don't have the square root. What I can sum, what I can subtract, what I can times. There's nothing I can sum them or subtract them. I cannot do anything to that. So I must find a domain which have two graphs in it. I can do the operation sum or subtract or times. So that's why I must have an intersection between the domain. So no matter it's sum or difference or product of functions, I must all find the intersections between the graph, okay, the intersections between the domain. That's the important thing. That is possible to be a 1 mark question of multiple choice in the final exam. Okay, what's the domain for the sum of this function? Okay, that's one possible mark here. Okay, let's keep going for the next one. Okay, addition of coordinates, of ordinates. Okay, so sum of graph basically means I sum the y value. So there are some special points. I cannot find 100 points and try to make the graph. Therefore, I will try to find some key points. Okay, there are some points you must label. Same as when you sketch graph, there will be turning point, there will be intercept, you must label. So same as sum of graph. Sum of function, you must have, okay, first of all, you will have intersections when f8 equals to ga. Okay, when x equals to a, both functions give you the same graph, which means it's the intersection. Okay, which means it's the intersection. Because when we have the same x, we have the same y, is where they intersect. So for that a value, it will be twice as high as before. Okay, you need to, because you sum them. For example, when x equals to 1, f1 equals to 2, and g1 equals to 2. Therefore, f plus g1 must equals to 4. So it's twice as high as before. Okay, you increase that by another height. So the next one is one function equals to 0. Okay, ga equals to 0. So the sum will be still the other functions. So if you have f1 equals to 0 and g1 equals to 2, so f plus g1 will still be 2. Okay, so you must label that point out. The graph remain on one function. And the next one is fa equals to 0, ga equals to a, f plus a equals to n. That's the same case, number 2 and 3. And next one is if fa equals to n, ga equals to negative n, which they have the same distance go up and go down, that's the case where the intercept occurs. Okay, yeah, n plus negative n, that's a 0. So you have x-intercept. So that's for intercept. That's where you find your intercept. And the next three thing is generally talk. If fa and ga both greater than 0, then your sum of function must be greater than both graphs. Okay, if you have fa here, ga here, your result graph must above those graphs because you add them. If they both smaller than 0, when you add them, they need to lower than all the graph. Okay, if they both smaller than 0, there needs to be a lower point than those original points. If one greater, one smaller, the graph will be in between. Okay, one greater, one smaller than 0, the graph, result graph will be in between. Okay, that's something like you need to think about. Okay, that's something you need to think about where your graph will go. We'll do some examples later. Okay, let's think about next one. Subtractions of ordinates. Subtraction is same as add the negative of the graph. Okay, if you have gx, you just negative the graph, flip the graph first, and then use the same as sum of graph. Okay, subtract and the sum will be the same. You just flip the graph to by x-axis, and then you sum them again. Okay, multiply. Okay, multiply is interesting. If you have multiply, you're looking for 0. Okay, you're looking for zeros. If one point is 0, then the result must be 0. Okay, if one point is 0, the result must be 0. 0 times anything will be 0. If they both greater than 0, then the result will be greater than 0. If they both smaller than 0, the result will still be greater than 0. If they one greater, one smaller, then the result will be smaller than 0. Okay, so that's where you're trying to allocate your graph. Okay, you can see this point greater, this point smaller. I will have a point smaller than 0. That's what you need to think about. Okay, now let's have a look at example 1. So if fx equals to square root x minus 2 for all x greater than 2 and gx equals to 4 minus x for all x smaller than or equals to 4, I need to find the intersection between the domain first. Okay, I have 2 and 4. If x greater or equals to 2 is this way, x smaller or equals to 4 is that way, so the intersection will be x belongs to 2 to 4 inclusive. Okay, 2 to 4 inclusive, that's the intersection between the domain. Now I want to find the rule for f plus g. Okay, if I want to write that into function notation, let's revise function notation again. So the rule is called f plus g. Okay, the rule is called f plus g. Dot dot, I will say what's the domain? The domain is 2 to 4. Okay, that's a fixed notation mapping to R. Okay, arrow R, comma, that is fixed. I will say f plus g, give the variable will be x, so it's f plus g, x equals to, okay, describe the rule. What's the rule? The rule is add them up. So it's x minus 2 plus square root 4 minus x. That's it. Okay. And now I want to figure out what is fg3. So I just substitute x equals to 3. Substitute x equals to 3. So square root 3 minus 2 plus square root 4 minus 3, that is 2. Okay, 1 plus 1 is 2. So next one is talk about fg. Fg is the name of the function. Still 2 to 4 is the domain mapping to R, comma fg x. Okay, this function is called fg. The variable is x. So what you need to do is times them. So 2 square root times together, I can basically times this. Okay, times the two things together. So what is fg3? fg3 is square root 3 minus 2 times 4 minus 3, that equals to 1. Okay, I want to talk about a thing here. Okay, I will open this one. I will come back to the original page. Okay, I'll talk about one thing. So, fx equals to 3a plus 2x. Okay, I want to substitute x equals to negative a. Okay, this negative a is substitute to x, not substitute to a. Okay, how do you know that? This is x. Okay, follow the name of the function, that's the variable. The variable in this equation is x. So in this place, you can change things. You cannot change anything to those numbers or signs or coefficients. It's only this x can be replaced by something else. So if you really don't know what to do, if you really don't know how to do substitution, what I would suggest you to do is, okay, I will write down fx equals to 3a plus 2x. Okay. Now I will take off this x. Okay, I don't have this x. Now at the same, I will take off this x as well. That become an open box. Just remember, what you put in here will go that box. Okay, what you put here will exactly go to that box. Okay, so I will put negative a here because x equals to negative a. Therefore, my negative a will go here. Okay, that's how you do substitution. Or if we have fx equals to 2ax plus x squared plus a. Okay, complex, you don't know what to do. You just take off this x, put this as a box, and you have x squared, right? That become a box. Okay, what you put in the front, you will transfer to those two boxes. So let's say we put 3 here. Then you put 3 here, and you put 3 here. That's it. That's how you do substitutions. You should understand which one is your variable. Okay, I see a lot of questions, a lot of students substitute wrong thing. Substitute instead of x, they substitute a. So that's something you need to pay attention. Okay, let's come back to this. Now we come to a sketching question. Sketch the graph of y equals to f minus gx. Okay, minus gx. So gx is square root x. What is square root x looks like? Looks like this. But I want to subtract gx, so I want to sketch minus gx first. My minus gx will be the bottom one. Okay? Reflect by the x-axis. I will sketch x squared first. Let's sketch square root x, negative square root x first. So I will have 0, 0, definitely. I will have 1, negative 1. Okay, 1, negative 1. I will have 4, negative 2. Okay, so if I can connect that. Okay, that's my square root function. Okay, we have that. And let's sketch x squared. I don't need to sketch the whole graph of x squared because I don't have left hand side. I will only care about the right hand side with this graph. So x squared, let's put it on the dot. So I will definitely have 0, 0. I will have 1, 1. I have 2, 4. I have 3, 9, which is already outside here. So my graph will look like okay, I want to add them. I'll use a green color, maybe black. I'll use the black color to label the points, the new points. Okay, first of all, we can see an intersection at 0, 0. So 0 plus 0 will still be 0. So I'll have a black circle here. Okay, the next point will be when they are equal. Can you see when x equals to 1, that is 1, when x equals to 1, that is negative 1. So they have the same height. So this point will be a 0 here. At x equals to 1, here will be a 0. Can you see that? Okay. We cannot find any other point that have the same height now. Because after 1, think about the behavior of the graph. X squared increase really fast, right? But square root x will increase slowly. Okay, you square root it is increased. 1 to 1, 4 to 2, 9 to 3. It is increased, but very slowly. But think about the behavior of x squared. 1 to 1, 2 to 4, 3 to 9, 4 to 16. Like really quick, really quick. So this increase is actually much bigger than this increase. Okay? So this distance is always larger than this distance. Okay? See the distance difference? Like it's always larger. So remember what I tell you. There won't be any distance will be the same now. So you won't have any 0 here anymore. Okay? That's the only 2 x-intercepts here. That's how you analyze the question. After 1, there will not be any point have the same height. Okay? No same height because this is growing so fast, this is growing so slow. You won't have x-intercept anymore. Okay, then this one becomes the only x-intercept. And think about the behavior here. When we talk about if one graph is greater than 0, one graph is smaller than 0, when you add them, where the graph will be? Where the graph will be? Above, below, or in middle? In the middle. If one above or greater, one or smaller, that will be in between the graph. Okay. So if it's in between the graph, okay, if it's in between the graph. So think about here. That will be in between as well, right? It's all positive and all negative. And we start from here, and we have another x-intercept here. What do you think the shape of the graph will be here? It should be turning. It can't be all 0. It should be turning here. So the graph will be like this. Okay, does that make sense? Because you have two x-intercepts, and your graph must be in between the blue and the red one. How the graph will behave? The graph will decrease and then go back to this point. Okay, it will finally go back to this point. Okay, it cannot be a horizontal line. Cannot. It must go this way and then go up all the way here. Because this value is very small compared to the height here. So it just decreased a very small value. It's quite close to the original graph. And then it starts here, turn here, meet the x-intercept, and go up. Okay, so what you can see from this question? What you can see from this question? You cannot really sketch a graph with like confidence. I'm 100% sure that the graph will go this way. The points cannot directly tell you what is the shape of the graph. You need to analysis by yourself. Okay, you need to think what's the behavior of the graph. We have two x-intercept. What that means? Means the graph will turn some point in between those two values. Where it should turn? Here or below? Because it's positive and negative, the graph must be in between those two points, in between those two graphs. So it's like that. Okay? So it's not something for sure, you know for sure. It's something you think and you draw them. Okay? I give a pretty alright question. That's the level what we expect you to do. Okay? There will be some really complex question on your textbook, like really complex ones. I'm not expecting you to do those ones. Like, it won't be test on those ones. Don't waste your time on that question. So that's the type you know, like, will be on the test if there's one. Okay, that's the difficulty level. Okay, next one. Shh. Okay, composite function. Composite function is the most difficult thing, I think, in all the functions. That's what I think, because the students never learn the proper way, and they always think they know, and then they do not know, and they learn again, and they still don't know and learn again and again. So that's the topic I repeat again and again with students, because haven't really teach properly at the beginning. That will, for example, if you have already know composite function now, if you're not confident of doing composite function, please listen carefully here. Okay, every teacher have different methods. So my method will be quite different from other teachers. So I will go slowly. Make sure you understand it now. Okay, so what is composite function? Composite function is you put one function into another function and composite them to form a new function. So there will be a lot of restrictions. Think about when we do addition, a sum, difference, and product of functions, we just care about the intersections between the domain. Okay? We have domain 1, domain 2, we find the intersection. But composite function is not that easy case. Okay? It's not easy at all. So let's do an example for a composite function. Let's say fx equals to x squared and gx equals to x plus 1. I want to find g of fx. Okay, I want to find g of fx. So let's think about the value what we have. We have when x equals to 1. I want to evaluate g f1. That's what I want to evaluate. So I will evaluate f1 first, right? I will evaluate f1 first. So basically, is I substitute x equals to 1 into fx. I find out the value. What is the value? The value is 1. Let's make not make 1. Let's make that plus 1. So let's make that 2 to make you not confused with what we're doing. So I put 1 in, I have a 2 out. I have 1 in, I have 2 out. Okay, now my gf1 become g2. So what we have done now is we substitute that 2 into my gx. And what I have produced 3 out. Okay, that's what this composite function doing. So I have a function inside. I will evaluate that function first. I have a value out. I put that value into the outside function then. So I have x equal to 1. I put x equal to 1 into fx. I work out that value is 2. I put this 2 as the new domain for the function of gx. I have out my range of 3 finally. Okay, so when x equals to 1, my g of fx equals to 3. Okay, x equals 1, this thing equals to 3. So that's how composite function works. Okay, that's how composite function works. Let's take this off. I'm just explaining how it works. Okay, so the new function is called composite of f followed by g. We say that's g of fx. G of fx. Okay, g of f of x. Okay, now let's think about g of fx. Basically, I'm putting some x value in. Okay, I put some x value in into fx. I will have the range of f. Okay, I put all the x value, all the possible x value in. Which will be the range of f? Okay, what's the possible range for this f function? I will put the range of f into the g again. I'll put the range of the f into g again. And I have the final range for g of f. Okay, the range for the final range. Okay, the important thing here is two things. First, can this x fit in f of x? For example, fx is square root x. Your x can only be positive now. So first thing is, can this x be put into f? Okay, is that possible to put into f? Second thing, is this range suitable for the domain of g? Okay, suitable for the domain of g. For example, let's say we have x cubed here. Okay, we have x cubed here. We have fx is x cubed. What we have put x is all fine. Okay, every x value is fine. And what's the range for a cubic function? Will be r, right? What we can come out is r. Okay, it's everything. And now my gx function is a square root x. It's a square root x. Okay, the problem occurs here. Uh-oh, some negative values into square root x is not working. Okay. We stop here. We will go back to check what is possible to put into the square root x. What is possible to put into square root x is 0 to infinity, right? That's the thing I think is suitable to put into gx. Okay, now I want to produce 0 to infinity. What is the x should be? Can it be r? It cannot be r now. Okay, I want to restrict what I can put to produce what we want. What we want is this. Okay, produce from here. So I need to change the top value now to fit this. So draw x cubed. Draw x cubed. My x cubed looks like this. I want the value to be 0 to infinity. So I will have this part of the graph. What x can produce that part of the graph, which is 0 to infinity? Which is 0 to infinity. Okay? So what we have done is we think first, okay? Follow our logic, think first. Whether you can put into fx. Yes, it can put into fx. What I've produced out from fx is r. But r cannot put into square root x. Oh, okay, I need to go back. Okay, that's not working, I need to go back. I will go back to, okay, that's the aiming, I'm aiming for this range. This range is 0 to infinity. Now I want to find the x value, the domain, which can suitable for this range. Which I work out that I want 0 to infinity as my range, which is this part of the graph, and my x value will be this part of the graph, which is 0 to infinity as well. So my 0 infinity is the final domain for this composite function. Okay, this is the domain for the composite function. Not r minus, not r plus. It's this. Okay. Okay. when you understand this easy example, I will go for the proper example with you. So see this example, I leave a really blank page for you. Okay, for the function f to r, fx equals to x squared minus 1, g is 0 to infinity mapping to r, gx equals to square root x. Okay, quite similar to what we have done here. State why g of fx is not defined. Okay, let's say why it's not defined. First of all, under this notation, f is the inside function. Okay, g circle f is equivalent to g of fx. Okay, g is inside. What is behind? What is inside? Okay, I want to make that chart first to explain why it's not working. So I will put my fx in. My fx is x squared minus 1. I will produce something out, which is the range of f. I will put that thing again into my g function, which is the square root x. And note the domain of g will be 0 to infinity. Just put here to remind yourself what are supposed from this box. Okay, now let's put things in. I'll write to the left. Okay, what I can put anything in this function because it's a quadratic, there's no restrictions, and also the function notation tell you that is R is the domain. So at the beginning, it's okay for me to put any number because it's a square root function. No, the square root, the quadratic equation. And let's think about what can be produced from this equation. X squared minus 1. What is x squared minus 1? X squared minus 1 is here. X squared minus 1 is here, right? If you can sketch it, that's the turning point form. This is the 0, negative 1. That is 1, negative 1, and that is 1. Should label as coordinates form, but I have no space. Just keep like that. What's the range? What's the range for this graph? Range? Negative 1 to infinity. Okay. I have negative 1 to infinity coming out. Can it be negative 1 to infinity or not? No, because I can only put 0 to infinity here. So I will try to find the intersections between that. Okay, we need to find the intersection between that. So what's the intersection? Is 0 to infinity. Now I need to correct here to 0 to infinity. Okay, from 0 to infinity, I will go backwards to see the, okay, I want x squared minus 1 to produce 0 to infinity for me. So what x value should be? So the y value will be 0 to infinity. Back to the graph. Okay, back to this graph. 0 to infinity is here. Okay, that is the part with 0 to infinity. Okay, y value is 0 to infinity. So what are the x values? Can give those y values. So is this part of the graph and this part of the graph. So basically is R except negative 1 to 1. R except negative 1 to 1. That is the domain for the composite function. Okay, I want this green part, I want this green part, I don't want here. So I don't want here is R except here. So it's negative 1 to 1. I'm not excluding negative 1 and 1. Because negative 1 and 1 will give 0. 0 is perfect fine for square root function. So it's R except round bracket negative 1 to 1. So check again. R except negative 1 to 1 will give you the range from 0 to infinity, which 0 into infinity can put into the square root x. So therefore, it is working. So let's come to answer this question. So question A. State why f of g of fx is not defined. Because range of f is negative 1 to infinity and the domain of g is 0 to infinity. Negative 1 to infinity is not a subset of 0 to infinity. Therefore, g of x is not defined. G of f is not defined. Okay, therefore it's not defined. Okay, the second question asking is, define a restriction f star of f such that f of g f star is defined. Okay, so I want to restrict the domain of f to form f star, a new function. For this function, this range, like this composite function can exist. I have already found it out. Okay, I have already found it out at the beginning. So what I will say is f star will be r except -1 to 1 mapping to r, comma f star x equals to x squared minus 1. That's the new function.
Why is it excluding -1 to 1?
Because
including 0 in the
yeah, I'm not excluding that out. I'm excluding the number between that. That's a round bracket, which means I'm not include -1, 1. If it's a square bracket, means -1, 1 is not in it. That's a round bracket. I'm not excluding -1 and 1 out. So -1, 1 is still in my domain. Okay. Make sense? Okay, does that make sense, everyone? Okay.